Hey everyone, welcome back to another lesson in computer science. We are studying object-oriented programming in Java. We've been working a lot with the Greenfoot development environment, but I'd like to go back to BlueJ. If you would please open up the BlueJ environment and let's create a new project called Number. And I want to continue working in Greenfoot. I want to continue working with the power of subclassing, but there's a lot still going on that we need to kind of take a second to review. And I think that it's easier to understand sometimes when you are using the BlueJ environment. It's good for inspecting and looking at things. And I want to develop these foundational understandings before we go into the more complicated Greenfoot with the graphics and can have more fun. So I want to have another lesson that focuses again on subclassing and inheritance, but I also really want to get into type. Java is a strongly typed language. That issue is going to come up with this project we're going to do together. I want to get into running code from other classes and running code from within your class and the different ways that that happens. We're going to get a little bit more involved there. So this is the mathematics frameworks are an important part of computer science, and so many different companies make their own mathematics framework. The mathematics that comes preloaded with Java or Python and other languages are pretty basic. The one we're going to do today is not going to get too involved, but it's going to get a little bit more involved, at least than the Java one. I want to make a system for mathematics that is more sophisticated than the one that is included with us for Java. And so I want to just make a series of classes that subclass each other. The most and we could include imaginary numbers if you know what those are, but I want to just start instead of with the complex numbers this time. I want to just start with real numbers. So I'd like to make a class together called real. So if you'll just select real and make a new class. And right now, currently, if you can look down here at this interactive shell, the way that we enter real numbers into Java are with a double. So if I said double x equals 9.7, well, that's a primitive. And we've talked a little bit about how primitives are stored. They are stored directly on the memory. They have absolutely no support. It is a number. In fact, it's double, meaning double precision. There's a set of binary numbers for the whole number part, another part for the power of 10. It gets all very complicated, actually. But that's all it is. It's just highs and lows, ones and zeros written on a computer. If I try and run a method, there is no method. X dot, there's no method I can run. I can't ask it any questions about it. Any knowledge I have about that number has to come purely from my brain because all it is a set of ones and zeros. I want to change that. I want to make my code be able to tell me something about the number. So we're going to start with the real number, okay? And we'll just say public class. We want people to be able to use this class, real. Okay, and so I'm going to make a constructor that sets one value. So the only value that's going to define my real number is going to be its double value, which I'll just say value. Okay? And I'll make a constructor, public real, and it's going to take in a double number, and I'll use that number to set my value. What variable names you give your private variables is really up to you because I wouldn't see them anyway in my documentation. You do want a nice variable here because that's what your users will see to know how to make a real object, that they need a number, and they'll see that it's of type double. And I set that number to the value, and so now it's set permanently. Okay, so let's go ahead and just compile this class, and let's make a real. So I'm going to say real x equals new real 9.7. So now I'm using my class instead down here. I can hit X. I can actually bring it over to the workbench. It would not allow me to do this with just the primitive. And I can double click on it, inspect it, and you see there's a value. But there's nothing else. I don't have any methods except, well, actually I do. I have some methods that I've inherited from. I've inherited this from the object class. You see, all classes extend object. That's why we call instances of class and object, extends object. I can say that. That's there automatically. Remember, Java does a lot for you without you asking it. And you see it still compiles because it's an absolute true statement. Stylistically, though, we usually leave it off. That being said, okay, I want to also look at one other thing. I want to say, so I've got this x here. Oh, no, I need to do it again because I recompiled. So real x equals new real. I'll get another number, 18.9. And I'm going to print it. And you'll notice what it says is real at 716A9CE0. That is a hexadecimal number. That is the digit 0 through 9. And the letters A, B, C, D, E representing the numbers, the digits 0 through 15. Well, actually, A is 10, so A, B, C, D, E. There should be an F in there as well. Yeah, F. So that's your, what is that? That's your reference. So what's stored in X is a reference, and when you print it, you don't actually get the real information for what X is. So we're going to fix that. The first thing we're going to do is we're going to fix that. When you print something, what you call is a method called toString. And if you recall, we inherit some methods from object class. We were just discussing that. And one of them is toString. And toString, again, Java does a lot behind the scenes. It calls toString for you automatically anytime you try and print something. And you can see that it just prints out this memory reference that it's using to locate X. So it's really not interesting to us. It is of great value in some advanced computer science algorithms, but it's not of any value here. And we can always get it another way. So let's change that. So I'm going to write the method public string toString. And it doesn't take any parameters. And I'll just say return, because I have to return a string. And I'm just going to say value plus quote, quote. So Java will automatically change a double into a string if you add quotes to it. If you add it to another string, concatenate it, if you will. All right, let's try that again. I'm going to arrow up here, and I'm going to make another real number. I'm going to pull that into my workbench, and I, of course, could right-click on this as well. And when I right-click on it now, you'll notice that I have this method here, string. It's still listed over here, but it says it's redefined in real. It's a much more interesting thing, 18.9. And I can actually print my object now, and I'll get something more interesting from that. 18.9. So we've already made it better. I mean, it's still not much better than the standard double is, but we're about to fix that for sure. Okay, so if we're going to be able to use this number system, we need to make sure that we can do basic math with it, right? So I want to show you a little something first, okay? So let me pull up my little board that I like to draw on my paint here. So this is the way we do math normally. We say something like, okay, say I have a real number 7, and I want to add a real number 12 to it. We say 7 plus 12, and we get 19. And this actually works in Java for primitives. You can actually tell Java 7 plus 12 equals 19. That's not the way objects works. Objects behave through methods. You can't take an object and add another object. The only object I know of that you can do that is with strings, and that's when you combine two strings together, but that's a special case. Instead, what we're going to do is whenever we want to add a number, we're going to take that number, and then we're going to use dot operator, and we're going to use that operator, and then we'll put that number. So it's going to be the same order. It's just going to look a little bit different. It's going to be something like 7.add parentheses 12. And that will give us a 19. Okay? So let's do that. And so I'm going to return a real number. If you add a real and a real, you always get a real back, right? Okay. So public real, and I'm going to call this add. And we're going to be writing this method to add this real number to another real number. So I'll say real other. Okay, let me just go back to my diagram right quick. So when you're coding this here, that is this real number. And the keyword that in Java we use is this. In Python, they use the word self. But in Java, you don't have to say that. You don't have to say this dot. You can just put the variable or put the method. This here, this is other. What I just called other. This is my parameter, okay? So when I want to add these two numbers, and when I'm going to add their values, okay? So I'm going to say double. You know what? Let's write a method first for the. Oh, I'm sorry. I know, confusing. I'm going to write a method real quick. Public double. And I'm just going to call it get value. Because we have a private value, I want to be able to return it as a double. All right. And I wanted to do that because I want to use that here. Okay, so I want to add these two numbers, but I want to add their values, and the result will be a double. So I'm going to call this result. So I want to discuss all different ways I can do this. I can say this dot get value. So in my example here, that would be this number 7 here, okay? Because I'm saying this dot get value. Make sense? And then I'm going to add to that, and I want to maintain that order, even though with addition the order wouldn't matter, but it will in other operators. I want to do other dot get value. You've heard me talk a lot about if you want to call another method in the class you're working in, you just say the name of that method. Well, it turns out the reason why you just say the name of that method is because you don't have to put the this dot in front of it. And it's stylistically preferred not to in Java. Other languages do not allow that. You know, it's fine. I like it. It makes it very readable, but you need to know what's really going on. I'm calling get value on the object that we're working on right now. So I don't usually put that word this. Now you might be confused here because you're going to think, wait a minute, why do I have to call dot get value on a real object if I'm in the real class? Because when I'm trying to add 7 and 12, get value is 7. Other dot get value is 12. Because there's always, when we call add, we're going to have an object called this, and then we're going to say dot add, and we're going to do another object. Just saying a method without anything in front of it, without a dot operator, means run that method on this. Understand? I hope so. Okay, so that's why. Now, I know I'm going a lot into this, but one other thing, because we are in the class though, I could actually have made my result like this and said value plus other dot value. Because value is a private variable, but even though, so there is a little bit of difference because I'm in the class. You know, other is a real, I'm in the real class, I can access others' private parts. But you'll have to decide about that. I mean, to me, when you are writing code, and if you have a long chunk of code, you don't want to scroll all the way up to find the private variables. You'd rather just check your own documentation. And so I pretty much, even in the class I'm in, prefer to work with methods. It just makes sense. Oh, well, I've got a compiler, so it's not going to document. Oh, wait, it did. Oh, there. So you can see that I can go to my documentation. I can see, aha, that's how I get the value, get value. So really, the more you code, the more you're going to do everything through methods. Trust me. All right. Now that we got the result, we're supposed to return what? A double? No. Look at the word after public. The add method is supposed to return a real number. So how do I return a new real number within the real number class? Well, it is just like this. Return new. It's a new number, right? New what? A new real with the result. And it turns out I could actually skip this step right here, and I could take this entire chunk and put it right there where result is. And then it would all work together. But some people like to do things in 2 steps. It's up to you. You want to do it in 1 step, take that and just replace result with it right there. You don't have to do that. That works just as well. All right, I think it's time to try this out, don't you? So I'm going to just go make a new real number, and I'm going to make it 19.2. And then I'm going to make another real number, and I'm going to say 1.8. Now, if I add 19.2 and 1.8, I should get what, 21? So let's try it. Add that one. And what did I get? I got a new real number. Real1 dot add real2 returned a new number. Let's get it. Real3. Let's get its value. 21.0. 1.8 and 19.2 makes 21.0. It works. We added two real numbers. We got a new real number. So now we can add them. Well, what I want you to do is I want you to pause the video, and I want you to write the method to return a real number when you subtract, when you multiply, and when you divide. When you divide, yes, it is possible you could be dividing by 0, but that'll give a runtime error, arithmetic error, which is fine. So let's just assume they're not going to divide by 0. Okay? All right. Pause the video and try that code, please. Okay, so hopefully you had some success there. Here are my 3 methods. I went ahead and stuck with doing it in 2 steps because I think that's the easiest to understand. So you see we calculate the double using the get this value, and then we perform the operator, and then we use the other.get value. That gives me a result that is a double, and I use that to construct a real number and return it. We could even take the return new real result and make that into 2 more steps as well. If you wanted to, for example, on add, we could say real, I'll just say in equals new real result. So, and then I could return just simply in. But that, to me, that's getting a little bit redundant. But it is important to realize that you can create instances of the class that you're in inside that class. It's just kind of weird, but as long as the code works, there's no circular logic or anything like that. So that's the arithmetic. Let's make a power operator. You ready? Public real, and I'm just going to call it pow. And we're going to take a real number and put it to the power of another real number. So square root and powers are functions from the math class. I call them functions. Another word for functions are class methods, also called static methods because they have the word static in front of them when you write them. We haven't really talked about static methods yet. It's coming. But for now, what I want you to understand is that static methods are not called on an instance of the class. A static method is called on the name of the class. They typically are methods that are just, they work the same every time. They're just utility, like taking a square root or something like that. So what we're going to do is we're going to get a result again, but we're going to use the math class. Notice I'm not getting an instance of math. You don't see me saying new math. I'm just saying math dot pow. Now the math dot pow operator takes in a number, comma, a power. So get value is the value that we are using, and other dot get value is the power. Okay? And then I will return new real number using that result. All right, I'm going to add one more. I'm going to add the square root, which is just usually called squirt, S-Q-R-T. Now, the squirt method does not have, a parameter because it's just square rooting a number. You know, if I say 9 square root, you know it's 3. I don't have to tell you what to square root it by. And so I want you to see how I do this. So I'm going to make a new real number. I'm going to say real n equals new real number, and I'm going to give it 0.5. We learned in algebra class that fractional exponents are actually radicals. They're actually roots. So, for example, 9 to the 1/2 power is equal to 3. It's the square root. 1/2 power means square root. So we're using the 0.5 power. And so now I'm simply going to return the result of calling pow within. So the pow, you can think of that as this dot pow. It's calling the pow method on this number, and I'm sending it 0.5, which will take the square root. All right. While we're on a roll, let's make another one. Public real, and I'm just going to call it root. And this time I will take in a parameter of the index of the root. Do I want it to be a square root, cube root, fourth root, fifth root, etc.? And so I'm going to make a real number. And if you want the third root, you raise it to the 1/3 power. So I'll make a new real with the 1/3 power. Now watch as I do this. Java will integer divide if you put a whole number divided by 3. If I put 1 divided by 3, Java will integer divide and say 3 goes into 1 0 times and say the answer is 0. So I don't want that. I want 1.0 divided by 3 so that I get that full about. But I don't want 3 because that would only be a cube root, actually. I want index. Whatever they tell me, index.getValue. Whatever they tell me to use, I'm going to do 1.0 over it, and then I'll return that power. Okay? So that is a lot. But let's add a couple more. I want to add methods that tell you whether or not this number is positive or whether or not it is an integer. The determining whether or not it's an integer is kind of tricky. But I'm going to tell you what it was going to be like. If you take an integer and you round it and then divide it by itself, you get 1. For example, take 4.0 and round it. Well, that'd just be 4. Now divide it by 4.0. You get 1. And that's what we're going to use. So for you, I want you to go ahead and write, to the best of your ability, public boolean, because we're going to return true or false, get is positive. I'll leave, that one's not too bad, so I'm going to have you write that one. So pause the video and write it. And then together we'll write get as integer. Okay, to tell if a number is positive, you just don't know if its value is greater than 0. So I'll return get value. Is it greater than 0? Get value greater than 0. This is a Boolean statement. It will resolve down to either true or false, and I return it. Perhaps you did something like this. If get value is greater than 0, return true, else return false. Well, there's nothing wrong with that, and it's not slow from the computer standpoint, but it's slow from my reading standpoint, and it's unnecessary. I'm saying if true, return true, else return false. Well, sometimes you have to do this because you do something different depending on whether it's true or false. If you're just returning true or false, just say return and then give the expression you want to evaluate to true or false. Return get value greater than 0. All right, let's do the is an integer. Public boolean get is integer. And watch how I do this. What I'm going to do is I'm going to round this value, and then I am going to divide it by itself and see if it equals 1. So it's math.round, get value, divided by get value. Does that equal, which means 2 equal signs, 1.0. So first thing it's going to do is this part. It's going to take itself, it's going to round it, it's going to divide it by itself, and then see if that, and then it's going to see if that result equals 1.0, which is basically 1, right? If it is, it will return that value as true. Let's try it. I'm going to make a number 19. And I'm going to say get is integer. True. Get it's positive. True. Let's make another one. New number. Negative 8.7. Get is integer. False. Get is positive. That's also false. Let's multiply them. And I can see the result. Pretty cool, huh? All right. Let's subclass. I'm going to make a subclass called rational. Rational numbers are any number that can be expressed as the ratio of two integers. All rational numbers are real numbers, but not all real numbers are rational. The most famous non-rational real number is probably pi. Pi is 3.14159. It keeps going forever. I cannot stop saying the decimals. They never have a pattern. It's completely random. Rational numbers, when expressed as a decimal, will have a pattern that will either be terminating in decimal, or there won't be a decimal, or it'll be something like 35353535, something like that. And that means it can be expressed as a fraction. So let's say public rational. Now, every rational is a real, so it makes sense for me to extend the real class. And then all of a sudden, I've got a pretty usable class now, and once I write the constructor, because I've inherited all those methods we just wrote. So let's say public rational. Now, what kind of things should my rational take into it? Well, it should take in probably a numerator and denominator, right? And they have to be integer values. So I'll say int numerator, int denominator. So I'm still having to use primitives. I'll call this numer and denom. I'm still having to use primitives here because I haven't made an integer class, and when I do, it'll subclass rational, so I wouldn't be able to use it inside rational. And those are going to be my fields. I'll say private, int numerator, private int denominator. Oh, I'm missing the word S. I'm missing the S on extends. That's better. And I'm missing the word class. Oh my goodness. There we go. All right. There. I wonder what all my color was. Yeah, it's difficult to code and talk at the same time, in my defense. Numerator equals numer. Denominator equals denom. All right. Well, what are you fighting me about? Oh, we have to call the super constructor. So do you remember the first line of every constructor is super, open, close parentheses. Unfortunately, the real class requires something there, right? It requires a parameter. So there it is. There's the error. Required, a double, found, no arguments. If I don't have that there, you get a really confusing error because it gives you the same thing. And you say, what are you talking about? I'm not even calling real. Well, you are. When you extend real, the first line of your constructor is super parentheses. So we need to change that. Even though you don't see it, it's there. We need to change that. And I want to give it the numerator divided by the denominator. And that'll give it as a decimal value. But here's the problem. These are ints. Because they're ints, this will integer divide. So if I gave it 3/4, this would actually call the super with the number 0. We fix that by saying double. Cast it as a double first. So this will cast numer as a double and then divide by the denominator. Okay? Also remember, super has to be the first line of any constructor. You can't do this later on. All right. So let's make a couple accessors. Public int get numerator. Public int get denominator. All right, and we'll say return denominator. Okay. Now let's add some let's take a look at what some of the things that we can do here. Oh, you know what? We need to fix the string. We need to fix the string. Otherwise, we're well, I don't know. Maybe. Let's take a look. I think it's worthwhile actually to look at this. Compile. So let's make it rational. So I say then to create a rational, you say the name of the class, then your variable name, I'll call it x, equals new rational. And my rational function command takes two parameters, a numerator and a denominator. So I'll say 4 and 5. Now let's print it. Earlier we saw that disgusting memory location stuff. Well, we don't now. What we get is the superclasses toString, which we did override. We're just not getting it as a fraction. We're getting it as a decimal. So let's go ahead and make an override to that. So we'll override toString, and let's return numerator plus quote slash quote plus denominator. Now we'll actually get our fraction nice and organized. Okay? All right, what I want to do now is I want to do some methods here. I want to be able to add and subtract. Now currently what's going to happen is that if I have this, let's say I have this rational number here and I make another rational. Okay, if I try and add to them like this, what I'm going to get is a real number result. So it didn't return a rational. Now, I want it to always automatically go upwards in the same way that in primitives, if you add an int and a double, you get a double. You divide a double and an int, you get a double. If we're going to add a rational and a real, I want to stick with the real addition. Give me that real back. But if I add two rationals together, I would really like it to be a rational. So let's do that. So we're going to write those methods. Public rational, so I return a rational, add. And I take in another rational. So if I try and add a rational or real, it won't call this method. It's going to look at the methods in real and say, okay, in real I have an add that takes in a real, but in rational I have an add that takes in a rational. So it will run the one that corresponds to the information that you give it. Now let's talk about adding fractions, okay? So when I add two fractions together, like 1/3 plus 2/5, right? Well, I have to multiply the top and the bottom. Whoops, that's the wrong thing. I need to get a common denominator, right? I multiply the top and the bottom of this fraction by that number, and I multiply the top and the bottom of this fraction by that number. I get 5 times 1 is 5, 5 times 3 is 15, plus 2 times 3 is 6, over 5 times 3 is 15, and my result is 5 plus 6 is 11, and the denominator stays the same. So getting the denominator for our answer is actually pretty easy. You just multiply the two denominators. So let's do that. So I'm going to call there'll be an int, right? Because if it's a rational number, they have a int on top and bottom. So int, I'm going to call it result den for result denominator is equal to get denominator. And yes, I could just access it as denominator since I'm in that class, but I like these methods. Get denominator times other.get denominator. Okay? So that's going to take this denominator and multiply the other denominator. It's going to be my new denominator. All right, now let's get the result of the numerator. Well, if you'll notice from what we did, we took this number here and we multiplied it that. This number gets multiplied there, and then we added them together. So I'm going to take get numerator times other.get denominator, because I multiplied by the other's denominator. And I'm going to add to it other.get numerator times get denominator. So I'm just kind of multiplying. Here's this here. This value 1 is get denominator. This is other dot get. I'm sorry, that's not get. Sorry. This is get numerator. My bad. And this is other dot get denominator. So I took get numerator times other dot get denominator. And this is other dot numerator, get numerator, and I multiplied it by get denominator. Okay? I think that's getting too crowded. I'm going to get rid of that. So that's how I did that. And there we go. All right, well, now we just need to return a new rational. So I'll say return new rational result num, comma, result din. All right. Now, what I would like for you to do is I would like for you to please write the subtract and the divide and the multiply methods to the best of your ability. And then what I want to do is break there, and we will come back and we will finish this project with the next video. So that's what you're going to do. In the next video, we'll go over the answers.